Piecewise functions, day 1. Please note the vocabulary, piecewise function, and step function. Alright, example number 1 is going to help you organize piecewise functions by first starting with table values and then transferring those table values into a graph. Now, the best thing to remember about piecewise functions is that they're just different equations smashed together based upon a certain value where you switch from one function to the second function. In this particular case, the value change occurs at the number 2. So when the value of x is less than or equal to 2, you will be on a line 2x plus 1. And when the value of x is greater than 2, you'll be on a line x on a curve x squared minus 4. So we will use the table to organize these values, and you'll be able to see where you switch from one set of values to the second set of values based on this particular problem right here. So by substituting x, or the values of x, into this equation, we'll get these corresponding y values. And because the switch occurs at the number 2, and because this part of the rule contains less than or equal to, this will be your closed circle. Likewise, because this part of the rule is just greater than, this will be your open circle. Then we substitute these values of x into the second function to get the remaining corresponding y values. Alright. Next, what we will do is we'll fill in the place where the lines overlap one another. And in this case, it's along the vertical line, x equals 2. Here at this point, we'll put our first closed circle. Okay, here at this point, we will use an open circle. Now, from this closed circle moving left, that is less than or equal to 2, we will draw the line 2x plus 1. Now remember, 2x plus 1 has a slope of 2 and has a y-intercept of 1, which looks like this. From this point here, we will be using the curve or the parabola x squared minus 4. The best way to do this if you're not using a line is to draw x squared minus 4. Remember, from your transformations of parent functions, that is a parabola that has been transformed down 4 units. I'm going to sketch in the entire parabola, and then I will erase the part that I am not going to use. This is a good practice to have, because then you can see that we are only using part of the curve. So notice that I will be erasing everything that is on the left side of the value 2. And so, to emphasize, I will continue or redraw the value that is to the right, or the part of the curve that is to the right of 2. And your piecewise function looks like that. Example number 2 is slightly different. Domain and range of this function. The domain and range is going to be negative infinity through positive infinity. Although there is an open circle, it is covered by a closed, so there is no break in the domain. In set notation, that is all real numbers. And likewise the range, negative infinity through positive infinity, or all real numbers. Now on to example 2. Okay, no table values for this one because you'll notice that f of x equals a whole number, and that means we have 3 horizontal lines. The first horizontal line occurs at 2. And that will continue until the value 3. Now this is kind of confusing, so pay attention. Okay? The reason we have a switch at -3 is that our first rule is there at -3. Now between the values of -3 and 6, they will have a horizontal line at y equals 5. So I will move my line up to y equals 5. I have a final rule here. Greater than 6, my line will now be the horizontal line y equals 8. Okay, and now to finish out the problem, I will draw my open and closed circles at each one of these breaks. The first one, you'll notice at 2, we have just less than. So that means we have an open circle. Open circle. The closed circle occurs on the next value at y equals 5. Notice likewise that 6 has just less than, therefore it is an open circle. And then greater than or equal to 6 will contain your closed circle. The domain of this function is all real numbers, -infinity through +infinity. And the range of this function, recall, is 3 separate values, 2, 5, and 8. Final example, example number 3. All right. Now we must use our follow our rules, fill in our table in the appropriate places, make sure that we are looking at what is and what is not defined. Okay, so less than -3, that'll be until this point, will be on the first function. Between -3 and +1, that's in this area, will be on the second function, and greater than 1, that's over here, will be on the third function. So here we go. Substitution, -10, -7, -4, and -1. Now, because this is simply less than, this will be your open circle, and the closed circle occurs here at this value. We'll continue on this function until 1, so we substitute our values here. At 1, because this is just less than, this is your open circle. And we will continue on our third function from 1 through 4, the rest of the table. Because this is greater than or equal to, this is your closed circle. Alright, now filling in the graph of this information, the place where we want to go is the switch of each of these functions. Let me zoom out so we can see the entire page, including table and graph. Okay, so at -3, we will begin with our value here. And that's going to be an open circle at -3, -1. Okay? I need to make a correction here. That is not a closed circle. That is open. And it's open because it's less than, not less than or equal to. Alright, our next open circle is going to occur at -3, +6. Open circle here. And finally, our open and closed circle will occur at 1, -2, and at 1, negative 2. Now because this is the same value, that open circle just got covered by the closed one. Okay, on the left side, we will begin with this function right here, which is 3x plus 8, slope of 3, and a y-intercept of 8. The next line will be negative 2x. That has a y-intercept of 0 and a slope of negative 2. And the third and final curve will be x squared minus 3. Again, we will draw x squared minus 3 and erase the parts we will not need. Now because I do not need this left side, I will not bother redrawing it. I'll simply erase this part right here. And there is our third and final function. The domain and range here is going to be negative infinity until this value of negative 3, union, negative 3 through positive infinity. Now the reason that's the case is because there's two open circles here and here, so that x value is removed. The range is going to be all real numbers because this value is covered up and that value is covered up. Negative infinity through positive infinity is your answer.